I'm Sarah Jensen, editor of OEM Off-Highway, and welcome to Design and Engineering Insights. Today, I'll be speaking with Timo Schempp, responsible for advanced development at elobau, about a recent project the company has been working on for an armrest design for tractors. So thank you, Timo, for joining me today.
Thanks for having me. Hello, Sarah.
So could you maybe start by talking about how or why the aISA project came about and how elobau has been involved with it?
We came up with this idea because a tractor, as you all know, is used in agriculture, on construction sites, in forestry, or even the municipal sector. So this brings many different operating scenarios with it due to many implements that are coupled to the tractor. To do all this, the only thing that stays the same all the time is the operator interface. So we had the idea to have a changing operator interface and make it adaptive, so it can provide the operator with an interface that fits the actual needs of the operator in each operating scenario. This was the idea we had back in 2014. At that point, I was working at the Institute for Agriculture Engineering at the University of Hohenheim. And we had the idea together with the Institute for Engineering Design and Industrial Design at the University of Stuttgart. But somehow an industrial partner was missing. And luckily in November 2015, I got in touch with elobau at their booth at the Agritechnica fair in Hanover. And they also had the idea and thought about changing operator controls and had a little demo on their booth. And after bringing all the ideas of the three of us together, we set up a joint research project funded by the Landwirtschaftliche Rentenbank, lasting from March 2017 till March 2020, and with the name aISA or aISA as an acronym for Adaptive Interface Systems in Agriculture Tractors. And from today's point of view, I would say this was an absolutely perfect project network because we had knowledge about agriculture, we had knowledge about ergonomics, we had knowledge about manufacturing of operator armrest, and actually this is also, in my opinion, a perfect example how science and research can collaborate with the industry to combine the best of both worlds.
So could you maybe provide an overview of the adaptive multifunctional armrest prototype developed for this project? Go into sort of how it works, what benefits it offers, and how it meets the goals that were set out by the project?
Sure, absolutely. So first of all, we do have a very clear design on our aISA armrest. We have an area A, this is this area, where you find all the functions that are related to the tractor itself, like cruise control, like the hand throttle, like headland management, steering system, 3-point linkage up and down, or changing direction. Then we have area B. This is for up to 12 hydraulic, PTO, or even aISA bus functions on the implement. And the neat thing is that area A and B can be operated, or actually half of area B can be operated with a hand in just one position. You don't need to move the hand to control area A and area B. If you imagine to have the hand like this, you can cover all this here. Also using not just your thumb, but your index finger and middle finger. Then area C provides a full joystick that can be either gone, like it is right now, or 2 rotary switches, or just 1 rotary switch. And we also have a very intuitive depth control for the 3-point linkage that is here, that you can see here. It is like having the linkage of the 3-point linkage in your hand. So this is very intuitive to fulfill the depth control on our armrest. Then we have area D. And area D has a mode selector for work, park, or road, and some shortcut buttons to directly activate or deactivate functions. The adaptive areas are B, C, and D. In B, we have roller switches for up, down, back, forth, or even gun, and buttons. In C, we have the joystick, as I already mentioned, that can be either gone, has one rotary switch, two rotary switches, or full joystick. And also the joystick, as the rotary switches can be used with a fully joystick for the third and fourth hydraulic circuit. And then we have the mode selector, and the mode selector is adaptive in a way that it activates or deactivates functions that are needed when you are in the field, like for work, or it deactivates or activates functions that are needed when you're on the road. And usually for each implement, you have a bundle of functions that you need to activate or deactivate. So this can be all done at once, and it's always all the functions that are related to the currently coupled implement. What is also unique are the displays. You can see here and here that can show functions that are related to the control inputs. So we can make sure that it's always the function that is operated and not the technology behind it. For example, for us, it's turning on or off the baler or mower and not the PTO anymore, or lifting or lowering the pickup of the loading wagon and not retracting or extending a cylinder anymore. So several operating scenario configurations are stored on this prototype and can be chosen via a switch selector. In an upcoming research project, actually starting next January, we want to make this plug and play. So this is more handy for the operator, that he can just connect the implement to the tractor, and the implement then tells the armrest the configuration that is needed to have a perfect usability for that currently coupled implement. So overall, the benefits is that the operator just gets what he or she needs to actually operate the coupled implement, and also in an advantageous way, in an advantageous economical way. Like, for example, having an up-down and then back-forth, and not just an up-down. So if you could imagine, there would be a function like lowering or lifting the pickup. If you're lowering or lifting the pickup, you also want a control input to lower or to lift. If you have a control input all the time going back and forth, that would not be complementary to the actually controlled function. So yeah, and with all this, we actually outperformed our research project goals, because at the beginning we just wanted to adjust or modify a currently existing state-of-the-art armrest, but when at the very beginning we actually realized that we need to set up a whole new armrest, and that's the result.
So would you be able to maybe demonstrate some of the unique features or aspects of the armrest to give our audience a little more insight into how it works or some of the benefits it offers?
Absolutely. So right now, state of the art with this armrest would be that the operator needs to change the operating scenario manually. And as I already mentioned, there will be an upcoming research project where we do want to have this plug and play. But to just demo this to you now, right now we would be in tractor solo mode. So everything is actually gone. The joystick is gone. The rollers are also like in a very hiding position. And just the front PTO and the back PTO would be able to control. And right now, for example, we could change that to manual tanker. And if I press it, you will see the roller moving, adjusting to the new operating scenario. And also the joystick is coming up. And then we've also got some new symbols coming here for example, the boom of the manual tanker to extract it, or the shoes of the manual tanker to lower it or lift it. And then we also got the one rotary switch on the joystick. That's like, you can imagine having a lid of a bottle. And if you want to close the trailing axle of the manual tanker, you just close it like the lid of a bottle. And if you want to open the trailing axle of the manual tanker, you just open it like the lid of a bottle. So we think this is a very intuitive way of controlling a trailing axle. And this would be also for changing to another operating scenario like the plow. Then you see again the rollers adjusting to what is needed. And also the joystick is coming out again. Now we do have two rotary switches for the working width of the plow. Then you can turn the plow. Then the height of the plow is all adjustable on these buttons and switches. And as you can, I also want to demonstrate you the front loader scenario, where you can imagine having a front loader on the tractor, and then we need a full joystick that is coming out right now. So give it a little moment. So as you know, we see you have a full joystick that you can move with all the 2 joystick axles, and we have the 3rd and the 4th hydraulic circuit, or we can even use this for the 3rd hydraulic circuit and use the 2nd rotary switch for changing the direction of traveling. Mm-hmm. So this would be a little demonstration what would be possible with this adaptive control armrest.
So is this a product then, or I guess what are sort of maybe the next steps? I know you mentioned there's another project going forward, or is elobau possibly going to use this product as any sort of inspiration for current or future product designs? If you could maybe talk about that a little bit.
Well, we take this as a base for our upcoming research project. I already mentioned one question before, where we want to make this plug and play. And for this research project, we also have SDF, Samedeutz-Fahr, as a tractor manufacturing, joining the network, and also CCI aISA for the communicating interface between implement and tractor. And this will start in January 2021, lasting for another 3 years. And after this, we hope we will be at a point where we can bring this new way of operating tractors to the market. But right now, as I already showed you, it's still a prototype where we do have some issues in the field. So we've already been in the field with that armrest, as you can maybe see in the video. So we had this armrest completely controlled, one tractor with that armrest, but there are a few steps to go to bring it actually to the market and make it plug and play for users.
Mm-hmm. Okay. So how do you guys maybe see this prototype or concept maybe fitting in with current trends being seen with operator interface designs in general in the heavy equipment industries?
Well, we do see that there is the amount of functions that are in the mobile machines are increasing. So with increasing functionality, you can either place a display on the machine to cover all the functions, or you can just put in some more haptic control elements to control all the functions. But then there is, especially for a tractor, there are operating scenarios where you don't even need maybe 50, 60%, 70% of all the functions in just a small amount. But you still have all the other functions around you on the haptic control input. So this could fits the trend that there is an increasing amount of functions, but you still keep the amount of haptic control inputs at the same or even almost the same level when you have just the functions related to the available control elements that you actually needed. And this is also, there is a trend that there is more and more displays in a tractor cabin. But if you talk to drivers, or you can also speak from my own experience, it is the better way if you're operating the tractor with a haptic control element. You don't always want, especially if you go over undulating terrain, you don't want to have the display all the time in your hand, controlling the whole tractor with the display. You rather want to have an haptic control element in your hand that enables you to also look before the tractor and behind it with the tractor, so you see where you go and you see what happens behind the tractor. That is actually the main spots where the driver is interested in. And if you can make sure that you can control input without looking at it all the time, what you would need to do with a display, this is very beneficial. So we see that there is, or it's not a question that the display is needed or necessary in a tractor cabin, but we still think that the haptic control inputs are necessary, or the operators or the users want them in the cabin.
Okay, great. Well, thank you so much for taking the time to speak with me today to provide some more insight into the aISA project and what you guys are working on.
Thank you, Sarah.